All right, what is up, everybody? This is day 2 of week 2, quarter 4 digital learning lesson. This one's going to be a geometry review. So the first thing you're going to want to do is get your warm up done, take the next 8 to 10 minutes and work on that. And when you're done, unpause the video and I'll be here to go over it. All right, here we go. Number 1, a pizza at Domino's has a diameter of 10 inches. If the pizza is divided into 8 slices, what is the area of each slice? The first thing I did was go ahead and draw in a circle. I cut it into 8 slices. I listed the information they gave me. They told me that I had a diameter of 10 right here. So I know that the radius would be half as big, 5. And since this is an area problem, I'm not going to use the diameter. So I'm going to go ahead and cross that out now. I know that my area formula pi times the radius squared would give me the area, but since I want 1/8 of the pieces, 1 out of the 8th, I'm going to multiply it by 1/8. Pi times 5 to the second power times 1/8 would give me the area of one slice right away. If you don't have a pi button, you can use 3.14. If you don't have a squared button or something that a second power button calculator, you can just do 5 times 5. And again, you can use a fraction or a decimal for the 1/8. When you do that in your calculator, you should have got approximately 9.8. Your answers will vary depending on what type of calculator and what kind of decimals you're using. Number 2, probability question. In a bag of marbles, there are 10 gray marbles, 3 white marbles, and 2 black marbles. What is the probability of reaching into that bag, pulling a white marble, not putting it back? That's a big deal. And then pulling another white marble. Well, the first thing I did was I went and drew the bag of marbles. I put my 10 grays, my 3 whites, and my 2 black marbles into the bag. The first thing they wanted to say, what is the probability of getting a white marble? Well, there are 3 white marbles to start out of a total of 15. If they take one of these white marbles out, though, and then they go to pull another white marble, you're going to notice that there's only 2 left. And now there's not 15 total marbles left, there's only 14 marbles left. So the probability of the first gray or white marble would be 3 out of 15. The probability of the second white marble after one is taken out and not put back would be 2 out of 14. I multiply that in a calculator and you would get 1 out of 35. Number 3, a scale factor ticket problem. On a blueprint, the scale drawing has 1 inch represents 4.5 feet. If the wall's height is 4 inches on the blueprint, what is the height of the wall in feet? Well, the first thing I noticed is that they gave me a scale and my units, which I can use to set up a ticket. So I know that inches are representing feet. I know that 1 inch represents 4.5 feet. And then in this problem, all I have to do was figure out, well, where can I put this 4 inches? Well, I think back to my ticket. I have my inches on top with the numerator. So that's where 4 is going to go. X represents feet. So that goes where my denominator goes. From there, I cross multiply. This one's even easier than the other day's warm up. 1 times x is 1x, and 4.5 times 4 is 18. So we would find out that x would be 18 feet. And then the last one, number 4. Well, in this problem, I have 2 things going on. I want the total area. So again, the other day we did one that went around the figure. This one wants the total inside. Well, I have 2 shapes. I have a rectangle with a length of 4 and 7, and then I have a semicircle with a diameter of 4. To find the area of a rectangle, I can do length times width. 4 times 7, that gave me 28. Well, over here, I have a semicircle. Again, my diameter was given to me 4. I know my radius is 2. I know that for my area formula, I want the radius of 2. Pi times 2 to the second power times 1/2. Since I have a semicircle, I need to multiply times 1/2. I would get an area of 6.28. Again, I want to combine these two areas. So the last step would be to add them together. And I would find out that I have a total area of approximately 34.28. Again, decimals may vary depending on the calculator. All right, today's review is going to be 3 main topics. We're going to do some circle work, some angle work, and some triangle work. First up, all of this should be a review, so I'm going to have you work these things out ahead of me for each slide. So on this slide, I would determine the radius and diameter of your circles. I listed your formulas that you're going to need: pi times diameter for circumference, and area, pi times radius squared. Remember, crust equals pi dough, apple pies are square. Easy ways to remember them. Again, if you don't have a pi button, you're going to use 3.14 in your calculator. So at this point, I would take these 2 circles. I would list your radius and diameter first, since this is what we always do first. And then I want you to find the area and the circumference of everything you see. Pause the video at this time. When you're ready, unpause the video and we'll go over it. All right, here we go. The first one on the left, this 6.5 was the radius. The diameter is twice as big, so I multiplied times 2 to get the diameter of 13. To get the circumference, I would do pi, or 3.14, times the diameter. Well, my diameter up top was 13. Pi times 13 would be approximately 40.8. Again, your decimals may vary. Up here, I have my radius already ready for me. Pi times radius squared. Again, if you don't have a squared button, you'll just do radius times radius. So I did 3.14 times the radius of 6.5 times 6.5, and I got an area of approximately 132.6. The question on the right, same thing. First thing I wanted to do was what information was given. They gave me the diameter. The diameter goes all the way through a circle and goes through the middle. So the diameter was 17. The radius is half as big. So I'm going to multiply that by 1/2, or do 17 divided by 2. Again, my formulas stay the same. Pi times diameter to find my circumference. Pi times 17 would give me approximately 53.3. And then to do my area, I know that pi, or 3.14, times the radius squared. 3.14 times 8.5 to the second power. The area of the other semicircle, or I'm sorry, the other circle was 226.8. Make sure these answers were right, and then we're going to move on to some semicircle work on this slide. Again, same thing I would do is figure out what information did I give you. Did I give you a radius, or did I give you a diameter? List those, write down your area formulas, your circumference formulas. Don't forget, you have a semicircle. You have half of a circle. Pause the video at this time, unpause the video when you would like me to go over them. All right, first one, the first thing that they gave us was the diameter of 12. Remember, a diameter goes all the way through, even a semicircle. The diameter was 12, the radius would be half as big, 6. Well, I know to find the circumference that pi times the diameter. You can multiply by 1/2 or divide by 2 at the end. I'm going to break these into two-step problems. I'm going to show you what the entire circle's circumference or area is, and then I'll show you what half of it is. So if you did pi times the diameter of 12, you would have gotten approximately 37.68. But again, I still have to multiply that by 1/2 because this would be an entire circle with a diameter of 12. But I have a semicircle, so when you do 37.68 times 1/2, you would get a circumference of approximately 18.84. Again, decimals may be a little bit off. Same thing, area, I'm going to do pi, or 3.14, times the radius to the second power. I'm going to break it into two steps. I'll show you the area, and then I'll show you half of the area for the semicircle. Well, my radius was 6, so pi times 6 to the second power would be 113.04. That's what needed to get multiplied by 1/2. And then the semicircle's answer should have been an area of approximately 56.52. So there's your two answers for that topic. Down below, this semicircle, they gave us a radius this time of 7.5 because it starts in the center and goes to the edge. It does not go all the way through the circle. The diameter of 15 would do that. To find the circumference, pi times diameter times 1/2, because again, I'm dealing with a semicircle, half of a circle. Pi times 15 would give me approximately 47.1, and 47.1 times 1/2. Oops, sorry, that answer should have been 23.5. Again, your decimals may be off depending on what type of calculator you're using. And then down below, I know that if I do pi times radius squared times 1/2, that would give me the semicircle. Pi times 7.5 to the second power would be approximately 176.62. That's what I wanted to multiply times 1/2, and then I would get an area of approximately 83 or 88.3 for this semicircle. All right, moving on, we're going to do some angle work. First up, complementary angles. Make these corner boxes. We know that these corner boxes are called right angles, and right angles add up to 90 degrees. So complementary angles are more than one angle that add up to a 90-degree right angle. Vertical or opposite angles, they form an X. They are angles that are congruent or equal to each other. They are the same. So the top angle is the same as the bottom angle when they are vertical opposite, forming an X. The left angle is the same as the right angle, again, when they're opposite or vertical from each other and they form an X. But true is that they are equivalent, they are the same, they are congruent. So if the top was 120, the bottom would be 120. If the left side was 60, the right side would be 60, and all four angles in an opposite vertical angle relationship should make two semicircles or one full circle, which add up to 360 degrees. And then the last thing we want to go over is supplementary straight lines. Remember, supplementary, straight, they are angles that add up to 180 degrees. Triangle theorem reviews. There's two things we need to know about triangles. One, the interior angles, the sum of the three angles inside a triangle add up to 180 degrees. So here I had a 65-degree angle, I had a 57-degree inside angle, and a 58-degree inside interior angle. When you add up 65 plus 57 plus 58, they would add up to equal 180 degrees. The other triangle rule that we deal with is the side theorem. That's talking about the two smallest sides when added together must have a sum greater than the third side. Okay, sorry, that says or equal to. It should just be greater than the third side. So again, if I had sides of 5 here, 5, 11, and 7, when they combine, they would make a triangle because 5 plus 7, the two small sides added together, have a sum of 12, and 12 is greater than that largest side, 11. From there, I would try these four problems actually out using those notes right there. Pause the video. When you're done, I'll be here to go over them. All right, here we go. First one, angle A and B are complementary. Well, I drew a 90-degree right angle. If angle A is 2n minus 10 and angle B is 20 degrees, what would the value of n have to be? Well, again, I know that angle A and angle B are complementary. They add up to equal 90 degrees. From here, I had to combine some like terms. I have negative 10 plus 20. When I do negative 10 plus 20, I have positive 10. So the real equation I had to solve in order to get n by itself was 2 times n plus 10 equals 90. Well, I have plus 10, so the first step I did was use the inverse operation of minus 10 to both sides. Positive 10 and negative 10 cancel each other out. The other side, 90 minus 10 is 80. Now I'm left with 2 times 80, or sorry, 2 times n equals 80, or is the same as 80. I said times 2, so I'm going to divide each side by 2, and then again, the 2n divided by 2 will cancel out and leave me with n just by itself. 80 divided by 2 would have to mean that n would equal 40. And again, that makes sense because if I wanted these two angles to equal 90, well, 2 times my answer 40 is 80. 80 minus 10 is 70. 70-degree angle A plus 20-degree angle B, complementary 90-degree relationship. Number 2, x and y are opposite angles. If angle x has a measure of 2x plus 15 and angle y has a measure of 75, we need to determine the value of x. Well, again, I could have placed these left or right opposite to each other. I could have placed these up and down opposite to each other. But the real key here is what is true about opposite vertical angles. They are equal to each other. They are congruent. They are the same. So the hardest thing to remember is that they don't equal 180 degrees. They equal each other. We already know that the right side 75 degrees. We already know the left side 75 degrees. They're just trying to figure out what would the value of x have to be in order to make it 75 degrees. So I could say that 2 times x plus 15 is the same as 75. From here, I want to use my inverse operations. I have to get rid of plus 15 by subtracting 15. 75 minus 15 is 60. I'm left with 2 times x is the same as 60. We said times 2, so we divide each side by 2. 2x divided by 2 leaves me with 1x. My goal to get x by itself, and then 60 divided by 2 would give me a value of 30. Number 3, angle A and B are located on a straight line. That means they must be supplement to each other. If angle A measures 2x minus 15 and angle B measures 1x, what is the value of x? So again, I drew a straight line. I broke it into two pieces. I labeled what I got from my word problem. I know that these two angles, angle A, 2x minus 15, plus angle B, 1x, add up to a sum of 180-degree straight line. Again, I've got to do a little bit of pre-work here. I've got to combine some like terms. I have 2x plus 1x. So really, I had 3x minus 15 equals a sum of 180 degrees. And that's the problem I had to solve. I used my inverse operations. The opposite of minus 15 is to add 15. Now I'm left with 3 times x equals 195. I said times 3. The last step would be to divide each side by 3. And again, we would find out that 1x has a value of 65. And last one, I know this one might look a little complicated, but it's really not that hard. This picture is just a complex geometrical figure. There's two relationships if you were able to break this thing apart. So again, the first thing I did was just kind of break apart the two things I see. I see a straight line and I also see a triangle. This missing angle is really important because without figuring out what this question mark is, I'm not going to be able to solve for n because n is kind of over here all by itself, and there's really the only relationship is that question mark, that missing angle. So I have two things here. All I did was kind of break this apart. I know n plus something make a straight line supplementary 180 degree. But the issue there is I'm not going to be able to solve for two variables at one time. So I know that n plus something is a 180 degree straight line. Well, I also know that that same question mark is a part of a triangle. So when I broke that triangle apart, I know that these three angles make the interior angles of a triangle, which also equal 180 degrees. Something, that missing angle, plus 60 equals 180. Again, this has one missing piece. I can solve for this. I just got to do a little pre-work, combine some like terms. I have two 60-degree angles, so I really have 120 degrees. Something, that missing angle plus 120 would make 180. I can figure out what that missing question mark was by subtracting each side by 120. Now I'm going to go back over here. I now know that this missing question mark this entire time should have really have been 60. I know that's true because 60 plus 60 plus 60 is 180. Well, now that I know that n plus 60 is 180 degrees, I can do the same exact thing by using inverse operations to isolate the variable n by subtracting each side by 60 and figure out that n was 120. And if I go back up here to this original picture and just kind of put all these missing pieces back in, think of it as a puzzle. If I have all the pieces of my puzzle labeled, okay, now I know that this guy was 120. I can kind of check and just make sure, does all the math work out? Well, I think about this. I have a straight line here. These two angles should add up to 180. 120 plus 60, 180 degree supplementary relationship. I also have this triangle with three 60-degree angles. Well, 60 plus 60 plus 60 is also 180 degrees. All the relationships check out. The math works out. All right, that ends today's lesson. The last thing you have to do today is go through and use the bit.ly down below, GeoReview 42B. Make sure the G is capital and the R is capital. Everything else is lowercase. It is 8 questions on problematic. Make sure that you're using all your formulas. You're showing as much work as you can. It's the only way that you should be successful with this, and using a calculator. As always, if you don't like your original score, you're feel free to complete the assignment again. I always take the highest score, and if you have any questions, make sure to send me any messages through email or Remind app.